Assalamualaikum. My name is Siti Mastura binti Maskor. Today I want to present my final year project, which is propeller performance analysis based on different motor constants. First of all, I will explain the problem statement for my project. In UAV, it is important to use a well-matching propeller in electric motor to achieve the best efficiency and to avoid undesirable outcome. So every year, there are many research that discuss about the development of UAV that is compatible to a certain mission with fixed motor and propeller sizing, and also the combination between different motor and propeller. But due to lack of information from the manufacturer, there is no exact solution to determine whether the combination motor propeller is good enough. Therefore, this research will analyze the correlation between motor constant, propeller diameter, and propeller performance. Next, I will explain the objective of my project. The first objective is to obtain different motor propeller matching performance, which is thrust, torque, and efficiency through static testing. The next objective is to determine the correlation between motor constant, different propeller diameter, and propeller performance. During my presentation of PSM1, I already discussed the introduction for my project. So for PSM2, I will only recap some information. So UAV is a type of aircraft that operates without human pilot on board. So there are several UAV companies in Malaysia, which is Transcorp, Poladron, Overtech, Aerodyne Group, and Geosense. There are many applications of UAV such as to support the public safety and first responder community, commercial. UAV also famous used in military and recreational function and many others. This is the literature review for my project, so I will only recap some information of it. So UAV technologies are become more advanced in the past few years. So there are many improvements that have been made for a drone in terms of power source, UAV propulsion system, structural, and overall efficiency of a drone. There are several elements that can affect the propulsive and electrical efficiency, such as choice of ESC, choice of propeller's material, capacity of battery, and combination of propeller and motor. So for my project, I will focus on combination propeller and motor. This is the list of researchers that research about the development of UAV in terms of combination, motor, and propeller that consists of their methodology which they use, different motor constant and propeller sizing, and also their result. Based on my understanding of literature review, I discovered there are several experiments that only tested one-to-one effect of motor and propeller or motor to multiple propellers until they obtain the parameters that they need, such as thrust, torque, and efficiency. But there are no correlation between motor and propeller matching due to lack of information from manufacturer. So this is the flowchart for my methodology. First of all, I will start with conducting the static testing with 3 different motor constant and 3 propeller sizing, and after that I will use some important equation to calculate the values that cannot be obtained from the experiment, and after that I will compare the experiment and theoretical values with the manufacturer's specification, and I will do curve fitting and data analysis for the propeller performance, and lastly I will determine the correlation between motor constant, propeller diameter, and propeller performance. Then I will explain the procedure of my static testing, where firstly I will set up the apparatus and connect with RC benchmark software. And firstly I will use motor KV1400 with propeller 6x4, and then I will conduct the calibration before I run the experiment, and lastly I will save the data. So after I complete the first testing, I will repeat the procedure with different motor constant and propeller sizing. So at the right top of my slide is showing the schematic drawing of my static testing, and the picture below shows the real picture of my static testing. So this is the motor specification and propeller specification that I've obtained from the manufacturer that I use for my project. This is the picture for BLDC electric motor and APC propellers that I use for my project. So for motor, I will only use motor constant KV1400, KV2400 and KV920. And for the propellers, I will only use propellers diameter 6 inch, 7 inch and 9 inch. So the numbers 6 times 4E meaning is 6 represent the propeller's diameters, 4 represent the pitch of the propeller, and E represent the electric powered aircraft only. Next is the important equation that I use to calculate the values that cannot be obtained from the experiment, such as torque, FOM, and overall efficiency. So for my project, I also referred to theories such as the axial momentum theory and blade element theory. Next, I will proceed to the result and discussion for my project. So this is a graph comparison thrust data for experiment and manufacturer against current. So from the graph, it can be observed that the data obtained from the testing, which is the orange line, and the data provided from the manufacturer, which is the blue line, does not have much differences. Thus, it can be concluded that the static testing is valid. So the next graph is a graph thrust versus RPM for three different motor constant and propeller sizing. So as we can see that the highest value of thrust is obtained when three different motor constant combined with propeller 9 times 6, but it will reach the lowest values of thrust when combined with propeller 6 times 4. It is the same for graph torque versus RPM for three different motor constant and propeller, where when three different motor constant combined with propeller 9 times 6, it will achieve the highest values of torque, but when combined with propeller 6 times 4, it will achieve the lowest values of torque. But it's totally different for graph overall efficiency versus RPM for three different motor constant and propeller. The highest overall efficiency is achieved when three different motor constant is combined with propeller 7 times 5, where the lowest overall efficiency achieved when three different motor constant combined with propeller 9 times 6. From the graph before, I tabulated some important data, which shown in table 1, the maximum thrust for different motor constant and propeller. So table 1 shows that KV920 and KV1400 achieve the highest maximum thrust when combined with propeller 9 inch. Meanwhile, motor KV2400 achieve the highest maximum thrust when combined with propeller 7 inch. It is the same for table 2, maximum torque for different motor constant and propeller, where KV920 and KV1400 achieve the highest maximum torque when combined with propeller 9 inch, but motor KV2400 achieve the highest maximum torque when combined with propeller 7 inch. It's totally different for table 3, which is maximum efficiency for different motor constant and propeller, which motor KV920 and KV1400 achieve the highest maximum efficiency when combined with propeller 7 inch, but motor KV2400 achieve the highest maximum efficiency when combined with propeller 6 inch. So propeller 9 inch have the lower value of maximum efficiency compared to propeller 7 and 6 inch, showing that the propeller size gave a major effect to the efficiency of motor-propeller combination. Next is table 4, which is the maximum RPM for thrust, torque, and efficiency for different motor constant and propeller. So the value of maximum RPM in table 4 is different from table 1, 2, and 3 because the value is taken for the highest RPM of the motor constant and propeller used. But the value of RPM in table 1, 2, and 3 is taken when the values of thrust, torque, and efficiency maximum. Then I will proceed to the conclusion of my project. Table 5 shows the summarization on propeller performance based on different motor constant. According to Table 5, propeller 9-inch have a good ranking in terms of thrust and torque but lack in efficiency. However, propeller 7-inch is the best in efficiency but moderate in part of thrust and torque. Propeller 6-inch have the worst ranking in terms of all three performance parameters compared to other propeller sizing. So 7 times 5 is the optimum propeller to be used for motor constant between kV920 and kV2400. It can be concluded that the motor constant kV does not affect the performance against RPM, but propeller sizing playing the major role in that part. Lastly, I will proceed to the recommendation part of my project. So there are 3 improvements that can be made for my project. So the first one is to conduct a dynamic testing by designing a new test ridge that can be evaluated in a wind tunnel to obtain the performance of propeller with different advanced ratio. Other than that, the values of lift and drag forces can be obtained from wind tunnel testing to get a more accurate value through analytic equations. And lastly, using CFD estimation and FL profile given by the manufacturer, coefficient of lift and drag can be obtained. So in future, it can expand the scope of the performance of combination motor propeller into more detailed analysis. Okay, this is the Gantt chart for my PSM1. And this is the Gantt chart for my PSM2. That's all from me. Thank you.